Hello students. Well, this is the last video which I will be covering in the topic triangles, and after this I will be taking the next chapter, which is circle. So if you have any doubts, you can comment in the comment section. So now let's take the 17th example on the topic triangle. In this question, a triangle ABC is equilateral triangle, and this is D is a point on BC such that BD is equal to 1/3 of BC, and we have to prove this. Okay, so let's make some construction. I'll draw AL perpendicular to BC, and then I will apply Pythagoras theorem. As first thing first, as the triangle is equilateral, so this perpendicular will bisect the side BC, which means BL is equal to LC. So now let's apply Pythagoras theorem in the triangle. First take this triangle ABL. Well, in triangle ABL we have AB square is equal to BL square plus AL square, and then take the another triangle. Let's take this triangle ADL. So in this triangle we have again AD square is equal to DL square plus AL square. So let this be equation 1 and this be equation number 2. So if we look at these two equations, we will see that we have AB and AD, which is present in our final expression, and we don't want all these terms. We don't want BL, we don't want AL, we don't want DL. So let's eliminate them. So first is BL. Let's try to eliminate BL. What is BL? This is BL. So BL, we can write BL is equal to half of BC, because AL bisects the side BC. Okay, now another is DL. So where is DL? This length is DL, this yellow length. So how we can find DL? DL is equal to this whole length BL minus this BD, this whole length BL minus BD will give us DL. So let's write it. We have DL is equal to BL minus BD, or again BL is equal to, again we'll try to represent these two terms in terms of BC. Here also we have BC, and ultimately we will replace BC with AB. Why? Because the triangle is equilateral and BC is equal to AB, which is also equal to AC. Okay, so this is our methodology to solve this question. So let's proceed. BL, again BL we will write half of BC minus BD. BD is given in the question that BD is equal to 1/3 of BC. It's given in the question, so I'm going to write it as 1/3 of BC. So if we'll solve this, we'll get DL is equal to 1/6 of BC. So let's substitute these values in equation 1 and 2. We have AB square is equal to BL, I'm going to write as BC by 2 whole square plus AL square, and again AD square is equal to DL, instead of DL I'm going to write BC by 6 whole square plus AL square. Let this again be 1 and this be 2. Now again we want to eliminate AL square, so let us subtract these two equations. So we have AB square minus AD square, and again I am going to write BC is equal to AB because the triangle is equilateral. So this side we have BC square, instead of BC I am going to write AB by 2 whole square, and again this AL will get cancelled, minus BC we have AB by 6 whole square. This term is BC by AB by 6 whole square. So again let's solve this. AB whole square minus AD, sorry this is AD, I'm so sorry, this should be AD square. Okay, AB square minus AD square is equal to, let's take AB square upon 4 as common, then we are left with 1 minus 1 upon 9. If we'll solve this, we'll have AB square upon 4 into the upper side we have 8 upon 9. So this get cancelled. Now let's again solve this. 9 AB square minus 9 AD square is equal to 2 AB square. Yeah. So let's again solve this. 9, it will be 7 AB square is equal to 9 AD square. Hence we have proved the final result. Now let's quickly take up the 18th example. In this question, we are given a quadrilateral ABCD with angle B is equal to 90 degree, and we are given this expression, and we have to prove that angle ACD is 90 degree. Where is angle ACD? This angle. This angle we have to prove that it's equal to 90 degree. So to prove this as 90 degree, if we can somehow show that the AD square is equal to AC square plus DC square, then we can say that angle C is 90 degree. This is the converse of Pythagoras theorem. What we are going to do, we will show that AD square is equal to AC square plus DC square. If we can show this, then we can say that angle C is 90 degree, converse of Pythagoras theorem. So first, what we are given, angle B is 90 degree. So what we can write is AC square is equal to AB square plus BC square. And again, we are given this expression in which we have AD square is equal to AB square plus BC square plus CD square. And again, this term we can replace AB square plus BC square with AC square. Yeah, so let's do this. AD square is equal to AC square plus CD square. So hence we have proved this Pythagoras theorem, and hence angle C is 90 degree. Now take up the 19th example. In this question, equilateral triangles are drawn on the sides of a right angle triangle. So let's first draw a right angle triangle, and the question says that let this be A, BC. This is a right triangle. Then equilateral triangles are drawn on the sides. So on all these sides we have to draw equilateral triangle. So let's draw this. On this side also, all these triangles are equilateral. So on this side also, this is the equilateral triangle. Then we have to prove that the area of triangle on the hypotenuse, let this be E and let this be D and let this be F. So what we have to prove, that the area of the triangle on the hypotenuse, that is area of triangle ACE, is equal to sum of the areas of the triangle on the other two sides, that is area of triangle on this side, on the side AB, that is triangle AFB, triangle AFB, plus area of the triangle BCD. Okay, this triangle plus this triangle is equal to this triangle. This we have to prove. So we'll always starts with the basic. Area means half base into height. So let's draw the height for all the three. For all the three triangles, and let this side be x, BC is equal to x, AB is equal to y, and let the hypotenuse AC be h. So can we find this length, this height length? If we are given the sides, can we find the height? Yeah, of course. This is also x, this is also x, and this side is also, all sides length is x. And as it is an equilateral triangle, so this length is going to be x by 2, because the altitude bisects the side. So we know this side, we know this side as x, this side as x by 2. So we can find this by Pythagoras theorem. So this side would be x square minus x by 2 whole square, which is equal to root 3 x square by 2. Yeah, we can solve this. This would be, we have to take LCM as 4, then we have 4 minus 1, 3 x square, and then we'll take the root over, because this is height square, and then we'll take the root over, then height will be root 3 by 2 x square. Similarly, this height will be this height. This height would be root 3 by 2 y. So this will not be square. This would be x, root 3 by 2 x. And similarly, this will be root 3 by 2 h. Here the side length is h. Okay. So now let's substitute all this value. We have area of triangle ACE. Let it be, first we'll find the areas of these two triangles. So area of triangle AFB is half base AFB, this triangle blue, base is y, so half y into height. What is height? Root 3 by 2 y. And again area of triangle BCD is again half, base is x, height is root 3 by 2 x. So let's add this. what we can take common? We can take common root 3 by 4 as common. We are left with y square plus x square. And what is y square plus x square? As we are given that this whole triangle, triangle ABC, is right angle triangle. So we have this length, that is y. We'll apply Pythagoras theorem. So we'll have h square, h is the hypotenuse, is equal to y square plus x square. So I'm going to replace x square plus y square with h square. So we have root 3 by 4 h square, sum of the areas of these two triangles. And let's see about this triangle, triangle ACE. So area of triangle ACE is equal to, again, half base is h, into height, root 3 by 2h, which is equal to root 3 by 4 h square. Hence, we have proved that the sum of the areas of these two triangles, which is root 3 by 4 h square, is equal to the area of triangle ACE, that is triangle on the hypotenuse, which is also equal to root 3 by 4 h square.